Their combinations give rise to endless complexities, the Platonic solids. In context, key figure Plato, circa 428 to 348 BC. Field geometry. Before 6th century BC, Pythagoras identifies the tetrahedron, cube, and dodecahedron. 4th century BC, Theaetetus, an Athenian contemporary of Plato, discusses the octahedron and icosahedron. After circa 300 BC, Euclid's Elements fully describes the 5 regular convex polyhedra. 1596, German astronomer Johann Kepler proposes a model of the solar system, explaining it geometrically in terms of Platonic solids. 1735, Leonard Euler devises a formula that links the faces, vertices, and edges of polyhedra. The perfect symmetry of the 5 Platonic solids was probably known to scholars long before the Greek philosopher Plato popularized the forms in his dialogue Timaeus, written in circa 360 BC. Each of the 5 regular complex polyhedra, 3D shapes with flat faces and straight edges, has its own set of identical polygonal faces, the same number of faces meeting each vertex, as well as equilateral sides and same-sized angles. Theorizing on the nature of the world, Plato assigned 4 shapes to the classical elements. The cube, also known as a regular hexahedron, was associated with earth, the icosahedron with water, the octahedron with air, and the tetrahedron with fire. The 12-faced dodecahedron was associated with the heavens and its constellations. Composed of polygons. Only 5 regular polyhedra are possible, each one created either from identical equilateral triangles, squares, or regular pentagons, as Euclid explained in Book 8 of his Elements. 13, sorry. I thought it was 8. Please excuse me. To create a Platonic solid, a minimum of 3 identical polygons must meet at a vertex, so the simplest is a tetrahedron, a pyramid made up of 4 equilateral triangles. Octahedra and icosahedra are also formed with equilateral triangles, while cubes are created from squares and dodecahedra are constructed with regular pentagons. Platonic solids also display duality. The vertices of one polyhedron correspond to the faces of another. For example, a cube which has 6 faces and 8 vertices, and an octahedron 8 faces and 6 vertices form a dual pair. A dodecahedron 12 faces and 20 vertices, and an icosahedron 20 faces and 12 vertices form another dual pair. Tetrahedron, which have 4 faces and 4 vertices, are said to be self-dual. Shapes in the universe. Like Plato, later scholars sought Platonic solids in nature and in the universe. In 1586, Johann Kepler reasoned that the positions of the 6 planets then known, Mercury, Venus, Earth, Mars, Jupiter, and Saturn, could be explained in terms of the Platonic solids. Kepler later acknowledged he was wrong, but his calculations led him to discover that planets have elliptical orbits. In 1735, Swiss mathematician Leonard Euler noted a further property of Platonic solids, later known to be true for all polyhedra. The sum of vertices minus the number of edges plus the number of faces always equal 2. That is, B minus E plus F equals 2. It is also now known that Platonic solids are indeed found in nature, concerning crystals, viruses, gases, and the clustering of galaxies. Plato. Born around 428 BC to wealthy Athenian parents, Plato was a student of Socrates, who was also a family friend. Socrates' execution in 399 BC deeply affected Plato, and he left Greece to travel. During this period, his discovery of the work of Pythagoras inspired a love of mathematics. Returning to Athens in 387 BC, he founded the academy, inscribing over its entrance the words, "Let no one ignorant of geometry enter here." Teaching mathematics as a branch of philosophy, Plato emphasized the importance of geometry, believing that its forms, especially the 5 regular convex polyhedra, could explain the properties of the universe. Plato found perfection in mathematical objects, believing they were the key to understanding the difference between the real and the abstract. He died in Athens around 348 BC. Key works: 375 BC, The Republic; 360 BC, Philebus, and at the same time, Philebus and Timaeus.